Okay, exams are just around the corner, and I know you need to get a solid handle on light and optics. Well, you are in exactly the right place. We are going to break down all the core concepts, using some really clear visuals to make sure everything just clicks. Let's dive in.
So here's our game plan. This chapter map shows you everything we're about to cover. We're going to focus on the really key stuff, properties, refraction, and the spectrum. Think of it as our GPS for this whole revision session.
And here's how we'll get there. We'll start with how light interacts with stuff, then get into how it bends and splits. After that, we'll check out optics in the real world, and then wrap it all up with a super handy exam checklist to make sure you're ready to go. Right, let's start with the absolute basics. What actually happens when a beam of light hits an object? Understanding this transparency spectrum, it's the foundation for literally everything else we're going to talk about. This image just lays it all out perfectly, doesn't it? Light can pass straight through something transparent, like glass. It can get all scattered by something translucent, like frosted glass. Or it can get completely blocked by an opaque object. And that last one is the big takeaway here. If light can't get through, you get a shadow. It's really that simple. All right, let's build on that. So, we've seen what happens when light gets blocked. But what happens when it actually passes from one thing into another? This is where it gets really interesting. We're about to explore refraction and dispersion, the amazing ways light can bend and split. Okay, first up is refraction. Now, this is a definition you absolutely have to remember for your exam. It's just the bending of light as it moves through materials of different densities. Simple, right? But so powerful. And this shows that exact point brilliantly. Come on, we've all seen this. The pencil looks totally broken. That's because the light rays traveling from the pencil up to your eyes are literally bending as they leave the water, which is more dense, and enter the air, which is less dense. It's not magic, it's just physics. So how do we actually use this bending of light? Well, that's where lenses come in. Look on the left, a convex lens, the kind that's thicker in the middle, bends all the light rays inward to a single point. It focuses the light. And on the right, a concave lens, thinner in the middle, does the complete opposite. It spreads all those light rays out. Now this slide is perfect for your revision notes. It sums up those crucial differences. So, convex, thicker, converges or focuses light, used in things like magnifying glasses. Concave, thinner, diverges or spreads light, used in peoples so you can get that wide view. Nailing these distinctions is so key. Okay, time for our second major phenomenon. Dispersion. This is another one of those core definitions you've got to know. It's the process where what we see as white light, like sunlight, actually splits into its 7 component colors. So white light isn't really white at all. It's a whole rainbow hiding in there. And what's the most incredible example of dispersion? A rainbow, of course. When sunlight passes through raindrops, millions of those tiny water droplets act like little prisms. Each one bends and splits the light, creating that gorgeous arc of color we see stretching across the sky. Okay, so we've covered the core theories of how light interacts, how it bends, and how it splits. Now let's see how all these principles are put to work in actual optical instruments you probably see or use every day. Okay, let's do a quick fire round on these. A pinhole camera, that proves light travels in straight lines. A periscope, it uses mirrors so you can see around corners. So cool. And a kaleidoscope, that uses multiple reflections to make those incredible patterns. See, 3 totally different devices, all running on the same basic rules of light. All right, let's get serious because this is the most critical part, your exam checklist. We've gone over the concepts. Now let's make absolutely sure you can use them to get those top marks. So when you get a question about an experiment, structure is everything. You need to follow this 5-step protocol every single time. State the aim, list the materials, describe the procedures step by step, detail what you observed, and finally write a clear conclusion that links back to the science. Oh, and please look at that big red stamp. Don't forget the diagram. It's worth so many marks. And to finish up, let's do a super fast review of the must-know vocabulary. A real image can be formed on a screen. A virtual image cannot. Magnified just means the image looks bigger than the actual object. And dispersion, like we just covered, is the splitting of white light. Make sure you know these terms inside and out. So there we have it. We've kind of broken down the architecture of light itself. From why a pencil looks like it's bending in a glass of water to how all the colors of the rainbow were formed. The real question now is, after seeing all the principles behind it, what are you going to see differently?